Okay, hello everybody. Welcome and thank you for joining us for the latest installment of our ongoing automotive webinar series. Now, today's session, we're going to be focusing on the hot topic of AEC-Q100. Now, what exactly does automotive qualified really mean? And for this, we've brought in today our automotive quality guru, Richard Oshiro. Now, just a couple of quick announcements before we start the webinar. If you have questions throughout the presentation, please go ahead and submit these through the Q&A option that you'll see inside of the Zoom menu. So it says Q&A. Go ahead and submit your questions, and we will hold those to the very end and address every single one of them. Next slide, please, Richard. Now, before we jump into the presentation itself, I just wanted to quickly point out a little bit of give you a frame of reference. Now, MPS started our automotive initiative back in 2011. So we've been going after this space for about 8 years now. And that was in 2011 when our first flip chip packaging was qualified for the whole company. We will have a separate webinar in the coming months talking about some of this advanced packaging for power products. So stay tuned for that. But we did join the Automotive Electronics Council in 2012. So we've been part of the AEC committees for the last 6 years or so. And throughout our 8-year journey, we have now come to ship over 200 million units of automotive grade quality products and reach certain really wonderful milestones, such as revenue growing to about $80 million to this year. So we've accumulated a lot of knowledge in this space as far as creating high quality, great reliability AEC-Q100 products. So now, without further ado, I'm going to turn it over to Richard Oshiro, who's going to introduce himself and go ahead and jump into this presentation. Richard?
Good morning. Let me introduce myself. I'm Richard Oshiro. I have over 30 years of quality experience, almost 20 of that in automotive. I am currently the manager for automotive and quality management system at MPS. Prior to that, I was hired on as the director of quality at Cypress Semiconductor in order for them to get certified to the ISO TS 16949, which involved 2 internal fabs and 1 assembly and test facility, each of which had their own quality management system. That was a little bit of a challenge. Prior to that, and more importantly, is I was the director of quality for a US-based assembly subcon, where we assembled a proprietary package for Ford. And there I learned all of the intricacies of working for OEM. And the phrase that we had at that time is, "Have you been driven by Ford lately?" So what we're going to do today is cover a little bit on AEC. I'll give you a background on the Automotive Electronics Council, give you a brief look at the number of standards and the ecosystem that is involved. MPS is a Q100. I'll explain that in a minute, but we'll cover temperature grades, reliability tests. We're going to do a little bit of a detailed look at several of the tests, and then we're going to give you some information on what MPS does beyond the AEC requirements. So in order for us to drive to the PPB level, parts per billion, we do a number of extra things here at MPS. And then we'll cover a little bit on MPS as far as grades are concerned of electronics. So the ecosystem is not just one document. You can see on the blue panel, the AEC-Q100 is the reliability test that goes on. But in the center of this diagram is IATF, the International Automotive Task Force specification for automotives, which goes in conjunction with the ISO 9001. So recently they were separated apart, you need to be able to be certified to both. The interesting thing with IATS 16949 is it allows for customer-specific requirements. And for there, you can get customers that come in and ask for particular things on PCNs or particular things like for auditing standards, VDA 6.3. And then all of the results of the AEC-Q100 would then be documented in a PPAP, and I'll cover that also. AEC, who is AEC? AEC was founded in 1993 by GM, Ford, and Chrysler, Delco. GM, Delco, Chrysler, and Ford. It has now been expanded to include the Tier 1 suppliers. There are some OEMs that are consulting on it. There are a large number of semiconductor suppliers, and the function of the AEC Technical Committee is to establish the qualification standards. If you join as a member, it's good because then you get to see what discussions are going on to improve the standards. They are reviewed every 3 to 5 years. There's been discussions with AEC, with the German automakers, VW and BMW, Volkswagen and BMW, in order to try to align so there's only one standard. So the value of being a member is really important. What's the whole deal? The deal is automotive consumer products like your phone. The phone companies want you to buy a new phone every year. So Apple introduces a new model every year. They want you to upgrade. The life of a phone is 3 years. If you look at an automobile is, the life expectancy is 10 to 15 years. My last car was 14 years old when I finally had to get rid of it. So in 14 years, you're looking for electronics and support that has 0 defects. And everybody says that's hard, but the example I use when I teach quality is how many errors do you want your child's doctor to make? So within all of us, we have a passion for 0 defects. It's just, how do we do that at work? How do we do that in building product? So why 0 defects? This was taken from a slide from an actual automotive company where they actually explained that automotive companies sell millions of cars for a large amount, so they are easy target to sue. So what you try to do is try to drive the 0 defects, because any defect on an automobile means that the owner is inconvenienced. You have to go to the dealer to get it fixed. So the issue is you want to keep customer satisfaction up. You want to keep warranty costs down. So the best way to do that is get 0 defects. Going to go through a little bit on reliability and why the issues are important. You have early life failures. This is where between fabrication, assembly, and test, there may be some issues that escape. You want to be able to minimize your early life failures. On the other side of the curve, you have wear out. So after 10 to 15 years, you're going to get life failures because they're wearing out. And then in the middle, you have this constant random failures that occur because of the environment, because of the use, because of, let's say, high power electrical lines. Those sort of things are going to be what causes a constant low level. You want to be able to reduce that as much as possible. So you combine all of those together and you get what the reliability guys commonly call the bathtub curve. So in here, what you're trying to do is minimize the beginning. How do you do that? Is you cover that by qualifications, by safe launch protocols in order to make sure your statistical limits are proper and sound. And then the bottom of the bathtub curve is covered by the AEC qualification. So let me go into the AEC qualification. There are a number of standards that have been developed by AEC. AEC-Q100 is for integrated circuits. AEC-Q101 is for discretes. There's one for optoelectronics. AEC-Q200 is for passive components. And AEC has recently released a multi-chip module for automotive. And as we go along with the release on the standards, the first release on the multi-chip modules was primarily for FPGAs, does not include the power management modules yet, but that will be coming as we begin to mature the standards. Down in the bottom in the fine print is a number of the supporting standards for qualifications. So you can see under Q100, there's early life failure requirements, which means that you need to be able to do your life test to the grade of the product. Charge device, there's some sampling differences than the standard JEDEC. The other thing that AEC has done is they've introduced a couple of generic standards that don't apply specifically to the commodity. For example, AEC-Q006 was a standard that was introduced for copper wire, and AEC-Q004 is a guideline that's in development right now in order to cover zero defects. So it's an approach to zero defects as it applies to semiconductor product. Key figures, 3 unique lots for qualification. So they're looking for different wafer fabrication lots, assembly lots. For example, on life test, HTOL, sample size is 77. You run the sample for 1,000 hours. A lot of times when we do qualifications on a new technology, we will run the life test longer than that, but the standard is 1,000 hours. For fabrication and wafer fabrication and assembly, statistical process controls are the requirement, and 1.67 CPK is the target. So if you're less than 1.67, then they're going to be looking for action plans on how you're going to reduce it, how are you covering it. And the number of failures that are allowed in any of the qualification tests is 0. Now, grade-wise, and this is important when we get into early life failure and how you sell your product, is most of our product at MPS is grade 1, which means that the ambient temperature range for that grade is minus 40 degrees C to plus 125 degrees C. We're working on products on grade 0, which extends that operating range to 150 degrees C. So, key test categories. There's a big matrix for qualifications. It covers environmental stress, lifetime simulation, packaging and assembly, which would be like wire pull and ball shear, die fabrication, which would be wafer level reliability tests, like hot carrier injection, electrical verification, would be electrical distribution, in order to figure out, okay, how do you establish your standard distribution and what's in your data sheet. Defect screening, which would include statistical limits, and part average testing, which statistical limits are normally done over a period of like 6 months, whereas part average testing, you're down to the assembly lot where you're establishing here's the limits and take out the outliers. So the PAT, part average testing, is a good way to help drive to parts per billion. And then all of our product is molded, so we don't have to deal with cavity, but there is some tests that are there as far as mechanical shock and vibration. In detail, environmental stress covers temperature humidity bias, preconditioning. So preconditioning would be where you dry out the part, you do a bake, then you soak it for to the JEDEC standard, and that is to the size of the package. So for our package, you would do the soak, and then within 2 hours, you do that within 2 hours of the bake. And then what you do is within 15 minutes after the soak, no longer than 4 hours, you do a 3 times reflow, and the reflow for our product, since they're very small, is and lead-free, is we're doing it at 260 degrees C. Lifetime test, H2L. I'll give you an example here in a minute on a little more detail. I think I've covered a lot of this already. This is the lifetime test. The sample size for operating life is 77. You do the ambient temperature to the grade. The issue with early life failure is the sample size is 800, but the duration is only 48 hours. Here, what you're trying to do is you're trying to see, all right, over the population, you're trying to figure out, okay, can we meet the parts per billion effort, whereas because the sample size of 77 won't give you that accuracy. So one of the things that you do with early life failure is to figure out, okay, where do you stand in the beginning of that bathtub curve? Power temp cycling is you do power on, power off, cycling, ambient temperature, and I listed down here EVB. One of the things that helps us both on operating life and early life failure and power temp cycling is we use a evaluation board approach. So at my last company, we would do things based on a standard socketed board. We would have a little driver on the outside. But at MPS, what we're doing is we use an evaluation board to simulate the customer environment, the typical environment. The EVB also helps us when we come up with a customer issue, because we can easily modify one of our boards in order to match the customer application. We could actually do that testing on a bench, life testing, in order to do the stress where we don't have to create anything special. So the EVB really helps us as far as working with the customer and preventing issues from happening in the customer environment. Temp cycle, grade 1, minus 55 to 150. So this gives the margin over the product. You do test before and after at hot temperature. So here you're looking for a combination of stress on the die and package combination. Autoclave and HASS will give us an accelerated test for humidity and environment. Autoclave would be 121 degrees C, at 15 psi, 2 atmospheres for 96 hours. Unbiased pass would be 130 degrees C at 85% relative humidity. Process impact is if you do a change, there's a table established by AEC that says, here are the tests that you have to do. Here are if you do changes in design, in wafer fab, or assembly, there's a legend off to the right that gives you, here's the categories that need to be done. Do all qualification tests have to be performed for every new device? At MPS, we do. Even if we're doing a special customer character change, we will do 3 qualification lots. We will check to make sure that the product passes all 3. We will issue a qualification report. And how long is the qualification data valid? Obviously, if you make a change, you're going to need to do a requalification. But if you look at it, if I go back to the customer-specific requirements, you may have a customer that wants you to requalify the device at a specific time frame. So one of the things is not just a one-time only type of thing. You're going to be doing periodic reliability monitors on your product. PPAP, I mentioned PPAP before, production part approval process. It is basically a 200 to 300 page qualification report that shows here's the statistical controls, here's the process controls at the wafer fab, assembly and test facility, here are the qualifications by the calibration and reliability labs, here's the ISO and 16949 certifications, here's the qualification report. There may be customer information that required. You send this off to the customer after the qualifications are done in order to document that you have done all of the requirements for AEC. Here's an example of our burn-in bay. We have large areas set up in order to do burn-in. The part is in the middle. It looks like a customer application. And we actually can sell the EVBs, but this is how we do our burn-in and power temp cycling. Qualification, I'll quickly go through this. This is, we will do over 200 tests in order to do qualification over the operating temperature range and operating voltage range, different requirements. And to the right, you will see that we have established our first 4 EMI labs. This is CISPR 25 emissions testing. The first one has been established in Hangzhou. Here, what we do is we don't have to depend on an outside lab. We can work with a customer inside of a lab, work with them with their application, and help them work our products so minimize EMI issues. One of the other things that we do beyond AEC is we do a short-term reliability monitor on every lot before it ships. We do preconditioning on the sample, do 96 temp cycles, 48-hour autoclave, do a final test. If the lot passes at that point, then, if the reliability monitor passes at that point, we'll ship the lot. You can see that this is way beyond what most companies do. And we actually have, and there's a penalty to that, is we have to allow for manufacturing capacity. That's that little area in the pie chart. One of the things that we do in order to help get us to 0 defects is on automotives, we do a lot more in the way of dedicated assembly, enhanced process controls, different testing, and PPAP, which is required, which is what we require in order to get our product for automotive grade. I think that's it for me. There are additional resources so you can get a little more background on AEC. That's AEC-Council.com. If you want to contact us for specific information, please go to the alias automotive@monolithicpower.com. This is actually the third in a series of webinars that MPS has done. If you go and you take a look at our website, we actually have a webinar that was done by our EMI guru, and you can take a look at that as far as background on the EMI testing that we've done. So if there's any questions, you can go to the Q&A. I don't see any open questions at the moment.
So folks, thanks so much for joining us for the webinar today. We'll stick around for, I think, a minute or two in case anybody wants to submit any other questions through the app. Otherwise, we will be sending out a link to where you can revisit this presentation and actually access the material for download later today or tomorrow. And stay tuned for an invitation to our next one. Next month, we're going back to the EMI topic, and we'll actually be talking about EMI layout techniques. So thanks again for joining us today.